Hi everyone, my name is Thomas Kim. Today is July 23rd, 2019. This is my 11th episode Graph in C++. In this episode, we will learn about type dispatch and std integral constant. For more information about std integral constant, please double-click this link and refer to this creference.com website. Okay, let's get started. Start Visual Studio Code. On the CPP extension graph folder, click this button, 11, type dispatch.cpp, hit enter. Ctrl V, include talk play fun, output HPP, talk play fun, access stream, auto, handle, talk play fun, handle. We will create a function double remainder double n double d double. Okay, so please note that the third parameter, we defined the type, but we haven't defined parameter variable. Here we define long, q is quotient, we divide by d, and this is long. Now we return, original value is n minus q times d, like this. Let's test this function first. Void test remainder auto result d remainder. We will pass 7 and 4. We pass double, an instance of double. I will set it 70, 40, stream, result d, and there int main. I copy this function. Start command prompt. You should be in CPP extension graph subfolder. We will be using Clang compiler, std, C++ 17, 11, type dispatch.cpp, hit enter. CLS, so the remainder 7 divided by 4 is 3. So it works properly. Please note that we have specified type here, but we haven't specified argument variable. And when we call this function, we have to provide an instance. We have to provide an instance for double, the third parameter. Okay? This is the proper way. You have to keep this point in mind. And this last parameter is not used in this case. Now here, I define template class, template, type name type B, struct integral constant. I defined a struct here, static const sphere type value b. Okay, this b is the type. I defined value as a member, static member. Now using value type is type. I define the type alias and I define operator type operator value type constant no except return. It can be context pair too. Okay, we return this value. Also context pair operator, we need to specify return type constant no except. This is function call operator. This is conversion operator. Conversion to value type or just type operator. Function call operator. We also return value. Finally, we define another type using type. We define this integral constant. Or I will copy this part and paste it here. So we defined one type, two type, and one value and two operators. Now from this we define using truth type. Please note that this is type. Integral constant bool true. Please note that this is type. Okay, this is type. Using false type integral constant bool false. We defined two type. Now I define type function template type name type 1 type name type 2 struct is the same. I define static context pair truth type false type value false type. We defined an instance. We defined an instance of an instance value of a type false type using type false type. This is type. Okay, we defined here. Now I make specialization. I copy this again. And now this is type. We have to provide two argument type. Now these two types are the same. We assume type 1 and type 2 are different. Type are the same. Static, context period, truth type. Value, truth type. We defined an instance value of type truth type using type truth type. Now we can use this function, this same type like this. Void test is the same. Here I create another function. Bool is the same type. This is truth type. Please note that this truth type is defined here. This is a type. Okay? We have not specified the parameter here. Parameter name is missing because we won't use the parameter name. We only want the type. We return true. And I overrode another function. Bool is the same type. Now this is false type. Once again, parameter name missing here. Return false. Or we can provide the context pair here. Context pair. Context pair. Please note that is the same type is overloaded. This is different type. Here we can test like this. Stream is the same type. We are calling this function like this. Is the same. This is struct. We defined here int. This struct has a member value. This is instance. It returns truth type or false type, an instance. So we can put like this value. Okay. Here I will print out more int. Now I will copy this function call. Now this is double. I paste it to double. Okay. Now I will call this function and I disable it. In the command prompt, we build once again. Sorry. This conversion operator does not need return type. We will build once again. Okay. Hit A. So here integer is same type, so return value is true. In case of integer double, the return value is false. We are using type dispatch. This is type. Okay, this is type. We overloaded the function with different type. The primary reason for type dispatch is to resolve conflicting function overloading. For example, template, type name, real type, remainder, real type, and real type D, and we define another template function, template, type name, int type, real int type, remainder, int type, and int type D. So we have two template function. This remainder is supposed to take type double or float. In this remainder function, we are supposed to take type integral type. But in C++, we cannot tell the difference between these two template functions. These are template parameter. This is template parameter. It takes two parameter and D. The problem is the count is the same. Int type, these are two template parameter. This is two template function call parameter. In C++, we cannot overload these two functions. So we introduce another type. For example, true type, and here false type. Now this type parameter is different. We now can overload these two functions. Please pause this video and think about this for a few minutes. Now I will copy this function, copied, and paste it here, and I will rename the function impl. Also here impl means implementation. Long v long n divided by d, I would say q for quotient. Okay, then return n minus q times d. In this case, we can simply return n modulo d. Now I create another function, template, type name type, remainder, type n, type d. We call this function return n d is the same type int value. So if it returns the false type, then this function will be called. If this returns true type, I will modify it into double. If it returns true type, then this function will be called. If it returns false type, then this function will be called. Here, void test type dispatch stream the remainder 7.0 divided by 3.0 is remainder I will change the function name. Remainder. Okay? And it should be remainder IMPL 7.0 3.0. And I will copy once again, pasted it here. Sorry, we are calling this function. Remainder 7 divided by 3 . We fixed like this. Now I copy this function, copy, paste. I will disable this part. So we are calling this function. This function calls this function, and these two functions are overloaded. Now in the command prompt, we rebuild CLS remainder 7.0 divided by 3 is 1. Remainder 7 divided by 3 is 1. Or I modify it to 4. 4. I build once again CLS. Now 7 is divided by 4, the remainder is 3. 7 is divided by 4, the remainder is 3. In this case, we are calling integer function. In this case, we are calling double function, type for double. This is the essence of type dispatch. Before I wrap up this episode, I will remind you one thing more. In C++ 14 standard, underscore v suffix was introduced as below. In this same function, when we defined an operator, parenthesis function call operator, using this, C++ 14 standard also defines a function like this. Template, type name type 1, type name type 2, context pair bool is same b is same type 1 type 2 value. Please note that this is this type, and this true type is actually integral constant. Integral constant also defines function call operator. It returns the value v. So C++ 14 standard also defines like this. Instead of bool, we can just say auto. Okay? So this is defined since C++ 14 standard. We will test this function like this. Void test is same b. Stream is same b. Int is same b. Int. I will copy once again. Now is the same b int double is same int double. Now I will call this function copy paste. I will disable it. We build once again CLS. So int are the same type. Int and double are different type. Understanding type dispatch and also how this integral constant, true type, false type is the same type function. Understanding these are fundamentals for modern C++ programming. I will post complete source code to my own website extension.talkplayfun.com. By the time you watch this video, click this link, then you can download complete source code. And if you unzip this file, then under CPP extension, grep subfolder, you can find the complete source code of this episode. Please subscribe to my YouTube channel. Thank you for watching.